So in question number 10, it tells you a storyline, no? That the number of branches is equals to the branches you have the year before plus P times the number of branches you had the year before last. Okay, so based on the storyline, right? You want to first and foremost bravely write down the recurrence relation for number 10. What would you write? That un plus 2, according to the question, right, is equals to the number you have the year before plus P times the amount you have 2 years ago. If you get the blue color line, if you have gotten the blue color line, right, class, you've done it. The recurrence relation governing the scenario given in question 10. That's it. Simple. So if based on the storyline, you must agree that the blue color governs what is being repeated here. That the number of branches you have is equals to what you had last year plus P times you had the year before. That's it. So if you have done so, you are now ready to actually go on to the next one, the next part 2. In part 2, what they're trying to say is that you start off with 20 branches. You bought a new tree, and the tree comes with 20 branches. Okay? Then it says after 1 year, 1 year later, right? It becomes 25. Okay. So you read the part 2. If I'm able to pen down P0 as 25 and P1 as P0 as 20 and U0 as 20 and U1 as 25, you are quite done, you know. And now that P is given to you, you can then say that un plus 2 is equals to un plus 1 Once you have done this, right? Once you have done this, you are now closer to solving the equation, you know. First and foremost, you have the recurrence relation. You have all the conditions given the question. Tell me, John, what is left to be done? What is left to be done? You intend to solve the recurrence relation, right? You intend to solve the recurrence relation by first and foremost writing down the auxiliary equation. Kieran, what is the auxiliary equation in this case? M square, right? You use M square simple. And then from here, right? From here, you're supposed to solve for your M. The two M values, if you solve, right? If you solve, okay. So the moment you're able to solve this auxiliary equation, the next thing is you want to go on to page 13 and realize that in this case, it matches case 1. And now you have to actually exercise the belief. If you believe, okay, although I keep saying you believe. Actually, the reasoning, the justification is given at the back of the notes on page chapter 5. Right? You just go to the back of chapter 5 and see all the reasonings, the calculation to show you why case 1, 2, and 3 are all there. Right? So, armed with the belief, you can then say that the solution for this question is UN is equals to A minus 0.1 plus B okay, once again, after this line, what is left to be done? After this line, undone, what is left to be done? You're supposed to establish the simultaneous equations, right? How do you obtain the simultaneous equation? Okay, let's hear from Le. The first simultaneous equation that you can tell me. Le, do you get this equation? Because you know that U0, you know that U0 is actually 20. Then because U1 is 25. Okay, what is left to be done? You just solve them simultaneously, right? Just solve them simultaneously. So solving them simultaneously, you will get A equals to minus 2.5 and B is equals to 22.5. So therefore your UN is equals to negative 2.5, 0.1 to the power n plus 22.5, and you're done. You have solved the recurrence relation. And now to answer part 3 entirely, let me hear from the floor. Okay, Chenjet, what would you do to solve part 3 entirely? You equate, so Chenjet says again, Chenjet says equate the UN to 100, and then Chenjet go on. How do you solve this equation? Quiet again. Let's hear from Chenjet now. How would you solve this equation? Logarithm, is it? I think won't work, won't work. Anybody want to suggest how would you solve this equation? In fact, it's not equal. It should be, you say exceeds, exceeds. It should really be more than 100. How do you solve this inequality? Ananya, how would you do to solve this inequality? You're not sure? Tara, what would you do to solve this inequality? What is it? Here, right? Right, all the minuses are missing, right? Thank you for pointing out to me. Right, all the minuses are missing. Okay, now back to the same issues. Tara, how do you solve this inequality? One quick way is to point a GC, And then what you key into the graphical mode. The clever thing is you key into the graphical mode this expression. You key this into the graphical mode, and then you press Control T. The table of values will just show up. You just scroll down until you hit it. But supposedly you don't want to do it that way. Supposedly you want to do this by calculation. How would you have done it? If you want to do this by calculation, you want to observe that as n goes to infinity, or as n goes large, large, un goes towards what? Agree? If the n is large enough, the other term will diminish very quickly. Even as small as 10, right? Even as small as 10, this other term will diminish very quickly. This term, right? This term will diminish very quickly. So one way to resolve this is to capitalize on the fact that this is going to be towards this number, and you solve this inequality, and now change it. You can use logarithms. Okay. And believe me, if you do it this way, right, you will get a value of n that's going to be like this. Okay. Finish up the last slide again. Yeah. And then therefore the least n, okay. Thank you. Right, so it means 16 years and beyond. 16 years and beyond, you will have more than 100 branches. Okay, that's question 10 of your tutorial 5. Questions? Anybody? Question, Reese? Do you find this topic very easy? Although I didn't go through the notes from page 1, I have done it the reverse way, because I find it more effective, straight to the point. So I find that actually now, as you roll back, as you start to unfold it from the back, you find that things are getting easier, right? All you need to do is to believe, right? And now you see an example how you can form the recurrence relation, and how you can actually solve them and use it to make some deductions. Okay, that is actually number 10. Actually, number 11 is very interesting, Number 11 is very interesting. Number 11 is very interesting. San Chen, I bet you're doing math. Okay, anyway, in case you missed the lesson for any reason, again, like Sanchez is now busy doing, why are you something that bothers you? Can I go and take a look? Okay, anyway, there's a video, right? There's a video that I always push out, okay? Now, let's hear from the floor, how do we form the recurrence relation for this? this kind of question, right, requires you to think like the question, you know. There's like standard way of thinking, you know, that you want to actually see. It looks hard, but the way to think about this question is you ask if the dimension is 2 by n, right? The dimension is 2 by n. The dimension of the box is 2 by n. Okay, and of course you have n what do you call that? N rectangles, right, to be placed inside. You will find that no matter what, right, no matter what you do, on the ending part of it, right, on the ending part of it, you only have two ways to arrange it, no? Either you arrange it this way, or you arrange it this other way. Okay. Shh. Do you agree with me that the way to think, Aditya, the way to think is the ending, right? No matter what you do, is either the first way or the second way. Yes, end this way. So if you have the end case, right? The end case, and if it end like this, right? End like this, right? Bear in mind that here is actually n minus 2. Right? And therefore, here got so many ways to do it. Agreed? On the other hand, if you end with one rectangle standing in the tall position, this is n minus 1, then this got n x n minus 1 ways. Which means, which means the number of ways when you have n rectangles is actually the sum of okay. Then the question is, if you only have one tile and therefore it's 1 by 2, how many ways can you arrange? Okay, let's hear from Mia. How about x2? If you have 2 tiles and you have a 2 by 2 box to fill in, how many ways can you do it? Shh, quiet. Huh? What do you think is x2 equals to? x2 meaning to say, it is 2 by 2, and then you got two rectangles to place in. How many ways do you think you can do for x2? And Miak was trying to tell me 2 ways. She's right. Right, either both horizontally or both vertically. Right? Okay. So there you are, class. You have actually established the recurrence relation with the given condition. And tell me, Jie-Wei, what is to be done next? The belief. Right. You have to write down the auxiliary equation, which is m squared okay. If you solve for the m, okay, if you solve this for the m value using the quadratic formula, it will look like this. Okay. Okay, what do I do next after getting the value of m? You now exercise the belief, right? The belief. You therefore believe that your xn must look like this. Okay. This is case one. Case one, okay. And after this, what do you do? After this, what do you do? You have to form simultaneous equation, you know. The first simultaneous equation is this. And then you can form the second simultaneous equation. Okay, the class a bit, a lot of talking. What happened? Shh. Can you tell me what's going on? Bharati, the spokeswoman of the class, what's going on? Nothing. So you form the simultaneous equation, and what do you do with this? You then have to solve for A and B from there. So if you solve them correctly, you solve them simultaneously, right? If I wrote 3, it should be 2. It should be 2. Okay, so you solve them simultaneously. You solve them simultaneously, right? Your A will not be this, no? And therefore, your xn is equal to this. Class, can you tell me what's going on? Shh. There's too much talking, you know. Class, there's just too much talking. Okay, then you're asked to find x50. To find x50, right? You simply put n as 50. The number turns out to be 203650111074. This is equals. Nice, right? Which means if you have 50 rectangles to be placed in, it turns out to be so many ways. It's a very, very big number. Okay? Actually, if you have a GC, right, which is not allowed in the exam, if you have a GC, right, do you know that if you have a GC, let me tell you again, if you have a GC, you can go to the Excel spreadsheet in your GC, if you know how to use GC again. If you know a GC again, this is A, B, and C. You can potentially do this, no? You write this 2 as a 2 starting number, right? 2 starting number, and then you say that this entry is equals to B1 plus B2. Plus C1. C1. If you type like this in the calculator, and you type this as B1,
So how to do this without GC?
Solve this equation without GC, is it?
Yeah.
Okay. No, not possible. Not possible. Alright, so wait. To get this S50, right, it's possible. Just keep the calculator.
No, I said if you don't have
Calculator. Cannot.
that will be tested.
No. There could be a question of this nature, but you are able to do it still by hand, you know.
Okay.
If you have a GC, right, you can do this, no? And then you use a function, I'm not sure whether you know this function called fill. There's a function called fill in GC, you know. Only GC can do it. Okay, question to raise for question 11 of tutorial 5.
This number is the 52nd number of the Fibonacci sequence.
What sequence?
Fibonacci sequence.
Okay. I think it should be the 51st. Because Fibonacci, the original form start like 1, 1. This is 1, 2. You know, the original number is 1, 1, 2, 3, you know, but this is 1, 2. So this skip the first really. So this should be the 51st. Should be the 51st. 52nd.
Yeah.
51st. Should be 51st.
Yeah.